Alright, today we're going to be looking at section 6.2. That's the binomial distribution. So the learning objectives are laid out here. We want to determine whether the probability experiment is binomial. We're going to compute some binomial experiments, find the mean, standard deviation, and graph it. Alright, so start out, you're given a definition of binomial. This is going to be very important, the criteria. So how do you determine if an experiment is binomial? Binomial just means two outcomes, success or failure. So that's the main thing we're going to be looking for. So the experiment is going to be fixed, which means we know how many times we're going to do it. So either it's going to be done 10 times or 15, we'll have some count. This could refer to like taking a test. We know how many questions are going to be on the test. All right. Each trial is going to be independent, which means one does not affect the other. So like if I'm taking the multiple choice test, if I get number one right or wrong, it shouldn't affect my ability to get number two. Those are going to be independent questions. Three, there are two mutually exclusive disjoint outcomes, success or failure. So again, if I'm thinking about a test, even though there might be multiple choice, one of those answers is going to be correct, the other three are going to be wrong. It does not matter which one you pick. So if I say A is correct, it doesn't matter if you pick B, C, or D, all of those will be incorrect. So it's either right or wrong. And then the probability of success is the same for each trial. So the success and failure rate are not changing, they are staying constant. All right, so if you have all of these properties, then we have a binomial random variable. And then here are some of the notations that you will see when we're doing binomial. So N is the number of trials that we're doing the experiment. Okay, so the number of times we're repeating it. P is the probability of success for each trial, has to be the same. 1 minus P is the chance that we have failure. Sometimes you might see Q, the letter Q. So P is success, Q would be failure, or 1 minus P is failure. And X is going to be the number of successes. So we're trying to count how many successes we have in N trials. Also note that a success does not necessarily refer to a positive outcome. Okay, so sometimes in scientific experiments, if we're trying some experimental drug, we want to count how many people have a negative reaction or how many people die. And so success would be like finding how many people died according to this drug, because we want to know if it affects people in a negative way. So just because we say success and failure, success does not necessarily mean positive, and failure does not necessarily mean negative, but you will be associated with some probability, success and failure based on the experiment. So then you have some examples of trying to identify if it's going to be binomial or not, and you can kind of read through those, but I will spend time giving you some examples in my math lab. You got several different examples you can use, how to identify success and failure if it's staying the same. Here we start showing you how to compute it. Okay, so this is a table based on some prior examples. They give you success and failure and how many times that happened. This would be 4 trials, and so they show you you can have all 4 success, you can have success, 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 and then it goes down to failure. So this would be, and they're counting the number of success here. So you got 4, 3, 3, 2, and you have different number of ways that can happen. So 3 is done twice, and then you see it happen again. So if we're having 3 successes, that means the first 3 were success, the last one was a failure. You have the first 2, and then the third was a failure, and then the last one was success. And you got different ways that can happen. So you have this table that's showing you that, and we come down here and show you how to compute the probability if we were doing it by like brute force and by hand. This is using independent rule and addition rule for disjoint events to give you those probabilities. So that could be a lot of work, a lot of different things to happen. We go on to the next page and we get a formula. So this is a condensed formula to show you how to compute binomial probability distribution. So if you haven't seen combinations, I will show you how to do this. I will show you this by hand, and I will show you with technology. For the most part, we will use technology and or a table. So we have a table of probabilities given a specific probability of success, and I'll show you how to read that. But for right now, we have n trials. We're going to be choosing x of them to be success. So probability of success is going to be raised to the power of the number of success, and then you're going to do n minus x, which is the number of trials minus how many are successful. Will leave you with how many are failures times that failure rate. Then you have some examples, and they're showing you how to plug this in if you were using technology. This is the combination formula, which I'll show you that. But again, you might not have to use that too heavily. We'll use some technology. And then it really gets to be challenging based on what you're asked. So sometimes we might ask you find the exact probability of 1, 2, or 3. We might want you to find less than 3, so that would be 0, 1, or 2, so anything less than 3. We might ask you to find greater than, so you have to find up to 3 and above. You know that you're going to stop when you get to your maximum or number of trials. So these are different probabilities, so we'll have to interpret what we're being asked and then be able to find it. You might even also be asked to find between a certain number, so between 5 and 7. So I only want 5, 6, or 7. So I'll have to add those 3 up. I'm going to show you how to compute pretty much most of those, and we will use a table. So here's a table. These are in the back of the textbook. I'm just telling you Table 3, Appendix A. So if you wanted to get to the tables, you would need to go to the home. I don't want to go all the way back. This took me all the way out. So we would need to be at the home page for our course. We would go to e-text, and I want to go to the full textbook, this e-context. And from here, table of contents, if you scroll all the way down, that's when you can get to the appendix. So here's Appendix A, and if you arrow over, it says Table 3. So here we get binomial. So there's several different probabilities for different number of trials. So you got 1%, 5%, 10, 15, 20, 25, 30, multiples of 5. So if I had like a 42, these tables would help me. So they're given specific probabilities. This is the discrete, and if you keep going over, there's several different values of n that they're showing you how to compute for. You get to cumulative. Cumulative is different. It adds up all the probabilities. So 0, when you get to 1, it's adding 0 and 1 together to get this one. And then if you add up all of them, you get 1. So you got different tables. I'll show you how to use those. But you have to go to your main course and then go to e-text to get there. Otherwise, I'm in the assignment and I just go to e-text. It shows me this section only. Okay, so there's a binomial table that we can use that will be nice. And so this is showing you how to use that, and then you have some explanations of how to find it using technology. So you got graphing calculator, Minitab, StatCrunch, Excel. The text will show you all of those. Now we also want to be able to compute the mean and standard deviation, so the expected value. That would just be n, the number of trials, times your probability of success. This is going to be important. And then if you want to find your standard deviation, it would be the number of trials times the success rate times the failure rate. Multiply all those together, and you're going to do the square root, and that will give you the standard deviation. So those are going to be important measurements when we want to find the mean and standard deviation. Got some examples showing you how to do that. graphing binomial distribution, so they're kind of giving you some descriptions of what it looks like based on different probabilities. So if your probability of success is low, okay, that means the chance that you're going to get a low number of success is going to be high because you have a low chance of success. And then as you do more trials, the probability that you will get a success or repeated success in those high numbers is going to be very low. So low probability is going to be skewed to the right. If it's equal to 50%, it's going to be about half and half. It'll be about bell-shaped, symmetric. And then if you have a really high probability of success, that means it's going to be small chance that you're going to have a bunch of failures, and then a high chance that you're going to have a lot of success the more you do trials. So that's going to be skewed to the left. So that's what this is explaining. Based on your probability of success, you will have less than 5 skewed to the right, greater than 5 skewed to the left, and equal to 5, it will be bell-shaped. You also have different shapes based on N, so the number of trials. As your number of trials increase, and I think that's what this is telling you here, so you got some fixed probability of success. As your number of trials increase, more and more trials, your graph gets closer and closer to bell-shaped. So this would be like 0.2 probability, 10 trials. So 0.2 skewed to the right. Then we have 30 trials. It looks more normal. You still got a slightly skewed to the right. And we got 70 trials. This looks almost bell-shaped. So as N increases, you get closer to bell-shaped. And then here is a way to check the empirical rule, which we'll see that a little bit more as we go. And then here's some step-by-step ways to use technology, how to input it. In a calculator, it's showing you that the number of trials is your first input, probability of success is your second input, and X being the number of successes is your third input, and it will output exactly 8 trials. Now, if you want to do less than, it's showing you how to do less than, and then it doesn't show you the greater than, but we can manipulate to get that. It shows you Minitab, Excel, and then on the next page we see how to do it with StatCrunch. So do read over those, and then we're going to jump over to MyMathLab and solve a few problems.